Hi guys. So we've learned about circumference, we've learned about area of a circle, and then we learned about composite figures. So remember that a composite figure is a figure composed of multiple geometric shapes. Okay, so we're solving for the area of those composite figures. So that means that it's made up of triangles, parallelograms, rhombus, rectangle, square, trapezoid, circle. Just a shape that we don't have a real name for it because it's made up of real shapes. All right, so you have some of those formulas there. To remind you, I gave you steps with these that also had those formulas, but our steps for it are divide the composite figure into simpler shapes. Think of those shapes that you already know. Find the area of each simple shape, combine to find the total area. That might be addition, that might be subtraction. It really depends on yours, the problem you're working on. So I'm looking at this one. And this grid paper is nice because I can also count some of these, and they gave me some dashed lines, so it kind of tells me the shapes I already have. Oops, I clicked the wrong button. I don't want that. I want that. I think I turned it off. Okay, so I see a rectangle, okay, right there. And then I see two triangles. I see one here and I see one here. Sometimes they're the exact same and I could just find the area of one and double it. But looking at those triangles, they look different. And I can see that this one up here, it says 2, while this one says 3. So I have to be careful about that. They're not the same in this scenario. So I'm going to start with the rectangle. And I'm just going to put rectangle. Okay, so the formula for the area of a rectangle is base times height, or length times width for a rectangle. I'm looking at this. I can tell that this one's 4. I can even count that. And here to there is 8. Typically, they are not going to go all the way through because this outside shape, that dashed line, doesn't technically exist. So it's 8 to here, and then it's 9, 10, 11, 12, I believe. And I don't want to mess it up, so I'm going to count again. Oh, wait, this one's 8. This one's 3. 8 plus 3 is 11. So I did miscount. So I need to be careful when I do that. So this rectangle is 4 times 11, which equals 11 feet. 11, Miss Dolier, 44. 44 feet squared. 4 times 11 is 44. So the inside here is 44 feet squared. Now I need the two triangles, okay? So I'm going to change my color so you see that I'm referring to the triangles. And I'm going to do triangle 1, triangle 2. All right? So triangle 1, triangles are base times height divided by 2. And I'm going to write that one down because we don't have as much experience with it. Base times height divided by 2. So when I look here, this base is 3 and the height of the triangle is 2. So I'm doing 3 times 2 divided by 2, which I can do in my head. 3 times 2 is 6. 6 divided by 2 is 3. The reason that ends up working out that way is because multiplying by 2 and then dividing by 2 makes 1. They kind of cancel each other out is one way you can think of it. But it's just because they undo each other. So that equals 3. So I've got 44 and I've got 3 feet squared. I forgot about that part. Oh no, I can't fit the square. There it is. Okay, and then I have triangle 3. Triangle 2, triangle 2. Then I have triangle 2. So I have triangle 2. Okay, triangle 2 is down here. And, oh no, I need my draw feature. So it's 3 feet by 3 feet. So remember that formula is base times height divided by 2. I'm not going to write it again this time. So 3 times 3 divided by 2. Well, 3 times 3 is 9. And half of 9, well, half of 8 is 4. And then half of that one more is a half. So that's 4.5 feet squared. And then the last thing I have to do in order to finish up this whole problem is I need to combine all 3 of these. So I'm doing 44 plus 3 plus 4.5. Well, 44 plus 3, that's 47. So then 47 plus 4.5. Oh, scroll down a little too much, and I think my draw feature is going to turn off. 47 plus 3 would be 50. Then there's 1.5 left over, so 51. Oops, 50. I'm just going to scratch it out because hitting the eraser is annoying. 51.5 feet squared. And I want to double check that just because I know I make silly mistakes. Pretty sure all my division over there is good. So 44 plus 3 plus 4.5. Yeah, 51.5. I got nervous that then this is a video. You guys are going to send me messages being like, Miss Tolia, you got it wrong. And I'd be like, I'm sorry. Okay, so that was one shape. Here I have a different shape. Looking at this, and I see, oh, I need my draw feature. Okay, I see a square, and I know it's a square because it says 10 and 10. And then this looks like a circle, and it's actually half of a circle. They've literally cut it in half. Like I could draw it in the other half. I know that's not perfect. But so I've got a square, and I've got a half circle. So I'm going to start with a square because I feel really good with my rectangles and squares. So my square is 10 by 10, meaning I'm doing 10 times 10, which is 100. So I know that in here, this is 100 meters squared. Okay, I'm going to even write it there because I don't want to forget. Now I need the half circle. I'm going to treat it as a full circle first and then deal with the fact that it's only a half. Okay, and I'll put a different color so we can differentiate. So I've got the circle. My formula for a circle, and you can always go back to your notes. I know these, so I'm not going to scroll up and down, is pi times radius squared. Pi times radius times radius. Well, here for this circle, I don't know what they gave me. I have a line right here that's going through the center from edge to edge. So, oh, and if this side is 10, or sorry, if this side is 10, that means that this side is 10. That's how squares work. So that's the diameter. And half of that would be 5. Or I could even go from the center to the edge and count it. Oh no, of course my draw feature. Oh, 1, 2, 3, 4, 5. I can count it there because this one's on a graph, which is really nice. But it usually won't be, and I'd have to use this number as the diameter. So the diameter is 10. The radius is 5. Sorry, that kind of looks like a 16. It's supposed to be a 10. My radius is 5. We got this. Okay, so I'm doing 3.14 times 5 squared. So remember, 5 squared is not 5 times 2. It's 5 times 5. Radius times radius. So that's 25. 3.14 times 25. I'm using my calculator. I don't know that off the top of my head. It's approximately 78.5 meters squared. But this is not a full circle. This is a half circle. So in order to find half of something, I take that number, this one, and I'm going to divide it by 2, right? That's how fractions work. That denominator tells you how many pieces it's cut into. So I'm doing 78.5 divided by 2, and that's actually 39.25 meters squared. And you have to be careful with these problems because they kind of start to get all over the place, like mine is right now. So I've got that 39.25 and I've got that 100, and I'm going to combine them. 100 plus 39.25. Oh, I know that. That's 139.25. But if I had to type it in, I could type it in. That is my ending answer, the whole thing together. That's composite figures. So it's just breaking the shape up into shapes you know, solving for the area of each, combining together. All right, you guys got this. Bye.